It's an honor to be invited to join the University of Kentucky. And I really thank Dr. Phil Kern for helping to steer me in that direction, and also Vicki for the introduction today, and of course my dean, Donna Arnett. So and the faculty who are in those departments who said, okay, we'll give her a try. So thank you for the trial run here as being a chair. It's my first time, but it's very exciting. So I thought I'd also start from the beginning, because sometimes when you hear an introduction, you're like, oh my goodness, but when I look back in the history, it's like, how did I end up here? What was the path? And when I graduate, you do a postdoc, you're starting to think about your first job in your research career. You're like, all right, there's my goal, there's my sunset, there's my vision, this broad road in front of you, and it's all going to work out great, right? I don't know, that's what I was thinking. Everything's going to be awesome. Well, really what you get is a lot of detours. Your research takes a new pathway. You're confronted with a new grant opportunity. You're like, wow, that really wasn't in my area. So how do you steer down those, I'll call them new opportunities or detours that confront you? And I guess I want to give you the bottom line message of my talk today, which is if you engage community throughout your research process, you will be going on detours, but you'll never be at a loss for research ideas, and they'll always steer you in the right direction. So get your mentor team together and include community people, because we have to take off our doctorates, our titles, our skills, and we get together with local people who are impacted. Maybe it's their disease, and they have cardiovascular disease. What are they going through? Getting their feedback can really help in just navigating these detours that come around. Okay, so I want to show you a picture of the very first day that I came on this track. So Carolyn Beiler, standing there in the pink shirt, they're a group called Neighbors for Clean Air. And I was there in Marietta, Ohio, and I was in Cincinnati. It's about a 3.5-hour drive from the city. My doctoral mentor, postdoc, he said, you need to meet with them. He was invited to a meeting, and faculty, they get busy. So what do? They give it to the postdoc. So there I was, the postdoc who drove the 3.5-4 hours out to meet this community, and was just floored by the opportunity to work with them. They were very, very concerned about a manganese refinery in their community. They had approached EPA, they had approached ATSDR, they had knocked on politicians' doors, they even knocked on the door of the company. And for 10 years, after they had been knocking, had received no open door for conversation. So just to show you and orient you on, this is Appalachian, Ohio, and yes, Ohio does have Appalachian counties, and it does go down into Kentucky. So here's a picture of the refinery in Marietta, and then you can see it right there on the map. So they had tried to meet with the company and no success. Once I met with them, of course your brain starts churning. What can we do? What can we do? We've got to do something. They didn't know. They had access to the internet at the time, and they looked up and they saw one of the first things when you type in manganese were lawsuits for Parkinson's and welders. So welders suing, saying that they were getting Parkinson's disease from the manganese. So I think I have to slide next on where negative manganese can come from. But when I first thought about manganese, it was like, well, this is a nutrient. Like, why would you be so concerned about something that's in your food? It's in the salad that we ate today, and the soup. It's a key essential element. Our bodies need it for normal development. I quickly took a picture of a vitamin at the grocery store. Look, there it is. It's right there. It's not magnesium, just so we're clear. This is manganese. I love magnesium too, but I love manganese more. I don't know the negative effects of magnesium, but manganese we're aware. So what is this manganese? It's mined, and there's numerous mines in South Africa, even in Mexico. I believe there is one in the United States. And then it's transported by rail, brought to Marietta. In Marietta, that is the longest running refinery. So the picture on the far left is one of the pictures of the refining process. That core mineral is then smelted, heated at very, very hot temperatures. And as you can imagine, that would then release off particles. And as you can see, I want to go back to the facility. Do you see how dirty it looks? So brown, and you can see a change in the roof color. It wasn't always brown. That's from the deposits of manganese coming out of the stacks, and then also something known as fugitive emissions. So not just from the stack, but also from the windows and the release. So I always think about the workers, the poor workers who live primarily, live and work in the same place. Those individuals. But manganese is in everything to make our lives wonderful and modern. Batteries, in the steel production, whenever our economy takes off, steel is one of the hot commodities for new buildings, etc., and manganese is included in steel manufacturing. So I wanted to walk through this key. So this is like a toxicology term. My master's in it is in tox, so I have to give credit to like toxicology in that field. So this is the route of exposure, like how you're exposed. So should you be afraid if you're eating manganese in your diet, right? Or how else can you be exposed? How else can it get into the body? So here's like this diagram of the route of exposure. We're saying manganese is on the bottom, how much? And then your health, general health, is on the vertical axis. So there's very few, if any, reports of manganese deficiency. You can scour the literature, and there's very few. You can't not get enough. Even the littlest bit in your diet, you're good. But it's in homeostatic processes in your body. Your body keeps what it needs and excretes everything else. So it's in your diet, and it goes right out anything excessive. So you could keep eating the green spinach and the pineapple and tea and never, ever, ever experience toxicity from the amount that you get. However, when you breathe it, in those little fine particles that maybe come out of a stack, or maybe come off when you're crushing the metal if you're a worker, it can go right up through into your mouth and then your lungs and go through your blood system, or it can go through the nasal passages. They found this in mice. It goes through your nasal passages and then directly into the brain. So it can have neurotoxic effects once it reaches the brain. Now this photo on the far left is a mine worker. He was in Morocco, and this was one of the first investigations of manganese, and they actually termed it a manganese madness. These individuals would hallucinate, they'd have excessive crying, uncontrollable laughter at the wrong times, and also have this inability to maintain appropriate posture. Now this was at an extreme level of exposure, but so this is the ultimate. And so when I met with the community on subsequent numerous meetings, they had seen this work. They had read about it, it's in other papers, and we started then walking through a research study to answer their questions. And as a scientist, we were, a scientific community, it was how much manganese is good for you, and how do you measure it in the body, the biomarkers, like how do you know you've been exposed? And then if it's in a homeostasis in the body, maybe someone has a certain level, but it's okay, but another person, that might be bad, just because of their genetics and their metabolism. And also, what's the impact, let's say, of children? So I met with the community, took another scientist with me, also took my mom and my little baby, because, you have life that goes on, and we started writing down their research questions. So there were numerous sheets like this. We just kept going and going. But their number one question was, does manganese, does where we live, does that exposure affect our children, and particularly our children's brains, the cognitive development, They had questions on seniors, behavior, is it in our water, food. Milk was a question because there was a cattle, like a dairy farm nearby, and they had questions on, is it getting in, are the cows eating the grass, and then is it in the milk? So they had numerous questions. They were all brilliant. These are the same questions that the research community, we were asking. So I was just floored at their level of thought on this topic. It was dead on exactly what we should ask. School performance, etc. So they set out my road. They set out my pathway, my career. So this is a long-term haul. I plan to work with them for the rest of my life and pass it on to others to do this. So we created a research study, and we called it CARES also. I'm sorry, we did claim that name first. Communities Actively Researching Exposure Study. We wanted to have it positive. In fact, they said this study, I don't know if you've been to Marietta, but it's a tourist place. It was one of the first communities on the Northwest Territory. Marietta was named after queens in England and France. It was this was a very special place. They have a stern wheel festival. Tourists come in to visit, and they didn't want to hurt their economy, right? You're dealing with something in the environment because very, very sensitive. So we wanted a positive phrase for this research study, and I was like, CARES. And we bent these words, and they fit. Communities actively. So this community was an active player in the entire research study. They helped us even look at our comparison community, which is Cambridge, Ohio. We recruited moms who we wanted, they were ready. They needed an answer. And ideally, when you do a research study looking at long-term impacts, you really want to start in utero. You want to start when they've been fully exposed their whole entire life. But that would have taken a lot longer. Research already takes 5. It was a couple years. We got the grant in a year, and then it takes time. But we started at 7, 8, and 9 years of age, and we chose that they had to at least have lived there during the pregnancy. And I'll share a slide subsequently more about that choice of time frame. In terms of environment, we worked together with a team. We hired and trained community residents to go to each home and collect samples of soil and dust. We also did personal and stationary exposure. We collected a series of biomarkers, and then neurodevelopmental outcomes were cognition, behavior, social outcomes. Today we'll just focus on the cognitive. So as I had mentioned, we really wanted to get in utero exposure, because that relationship between mom and baby, moms are breathing it, what happens to the infant, that barrier between the placenta, what's going on, are they overexposed? We know the blood-brain barrier doesn't form until later, so how is this, what's the impact? So we didn't have that, but what we did have was another connection that my mentor gave me, was a dentist living in Australia. He was in Australia, who was developing a mechanism called laser ablation to go through a tooth, pull it out and then you have a tree ring of the time that the tooth is forming. And then he could measure, he could actually analyze those segments and determine levels, concentration of chemicals in that timeline. In this tooth, because he's a dentist and he knew this, when you are born, there is it's called your birth line. There's a line in your tooth that forms. Maybe it's the stress of being born, but there's a line that forms in your teeth. So you can actually then calculate, quantify the level of exposure to chemicals prenatally, and then subsequently until that tooth falls out. It's revolutionizing, I think, environmental exposure research. So a quick plug on this, I applied and received what's called the Wyatt Travel Award from the Provost Office. I invited this fellow, Manish Arora, and we just booked him. He's gonna come the day before the CCTS symposium, so it'll be April 20th. It's gonna be fantastic. And he's also going to join us in the symposium as one of the, hopefully, I haven't asked him this yet, but hopefully he says yes. And he can co-lead with someone else here at UK on biomarkers of exposure. So you have a chance to meet this amazing, he's so humble and kind, so I can't wait to bring him in. He's amazing. So we have this baby tooth. So now we can then look at early life exposure. We don't, Manish, I'm also bringing him here to say, come on Manish, I need the data. So hopefully it's a time we can transfer some information because we don't have all of it done yet. It's also very expensive. So another component of doing this research is looking, we know air is important, right? We know that air that they're breathing is key and critical. Not so much the diet, but the air. So EPA has this tool, it's called AirMod, and we had a student who ran the AirMod model, and the concentration is in the colors. So the darker, brighter the color, the higher the concentration. And you can see it's not equal across the community. There's a lot of variation. And that's because there's this hilly, topography plays a big role. But this is the average annual concentration. And those little buildings with the little flags on top are the schools where we would recruit, where we have recruited the children. So you can see most of the kids live in the town, Marietta, but others live across the river, and we finally did start recruiting kids who lived across the Ohio River in West Virginia. In that poor school, we've had numerous meetings on these kids are in that old, it was a very dilapidated school, they couldn't pass a levy. They ended up closing the school down. And moving the kids elsewhere, but that was a big concern for our team. Once you know that they're in a hot zone, so to speak, of exposure, we wanted to do something for that school. So working with the principals and giving them this information was really important. So I mentioned personal sampling, and this was one of our kids who participated, one of our participants, and they wore a little mini backpack around. So it was like, how do you get a personal device? So he wore a backpack. You can see the little badge or the button sampler right there, and it would clip on his lapel, and then there's a battery, and we stuck it all padded inside with a little GIS or GPS monitor so that we could know where he was going, and then translate it back to what his exposure levels were. But this is expensive, this is time consuming, and we could only do it for 48 hours. You know, you have to rely a lot on these kids, and they loved it though. They absolutely loved it, and actually their SIBs wanted to do it also. We'd come in with a backpack, and then all the SIBs wanted a backpack because it was like a cute, they felt very special. But the question that we had too was not only personal exposure, but if the AirMod modeling is much cheaper. So what's the relationship between the personal, like having them run around town with this backpack, costly, or if we could just model and then assign people and now also with our stationary sampling. So we did some analysis of the personal air sampling right here, and then across the modeled air. And it's not perfect, but they were pretty much in line. You can see some kids maybe went out of the area if they were over the weekend or something, but it was fairly comparable. So I have much stronger confidence in EPA modeling. And in looking at that, I like big infographic pictures when you're talking, not the deep dive on the science. But we wanted to also look at if we get these levels in their body, we have hair, we have blood, and we're collecting toenails and baby teeth. What's contributing? Because the community was interested in, is it our soil? Should we not be going outside? You know, we were addressing real world issues for them. And that is why we did all these extra things. We could have just taken the beeline approach to, here's your answer. But it took us on numerous routes. We did the AirMod modeling. We did this analysis of the structural equation modeling, looking at the contribution of these factors to the biological measure. So we had time outside, we had soil, we had dust, we had air. And then, because we collected the dust in the house. And then everything we looked at was like, what's contributing to the amount we found in their hair samples? And so it looks, based on the modeling of this subset, soil was contributing to the dust in the home. So they would be walking, tracking it in. So there's an intervention, right? You can think, okay, leave your shoes at the door. Maybe that could stop that pathway. Time outside was contributing. Again, kids running outside playing and then, shoes still on. But also air was contributing to the dust, and that's a bigger implementation and intervention. But we're thinking of ways to do that. So it was interesting to think that even their dirt in their yard was contributing to the amount in their child's body. So we're starting to think of ways that everybody could have access to measuring their soil metals concentration and make it, everyone, anybody who was curious about their soil levels could have those analyzed, and we're brainstorming ideas of that here. So IQ, that was our main, if we're gonna find something, it's probably going to be with child IQ. So that's where we'll start. And I have to tell you, a lot of the neuros, actually not a lot, all of the neuropsych components of this research study come from a legacy. I was at the University of Cincinnati that has a legacy of lead exposure research. So those people were on my team, and since manganese at the time was so new, I relied on the lead history and applied it to the manganese story. So IQ was very important to measure. This is Jody Alden with actually one of her daughters. This is an example of the tests and how that operated. So we hired people from the community to do the research. We have some statistical methods because every good epi study has a strong biostatistician, which is not myself. In this case, we had Dr. Heidi CRU from Cincinnati Children's Hospital. And then using these various methods, we were then able to look at not just the direct relationship between manganese and IQ, but also what about the nutrient capability of manganese, how central it is. We had to put that in our analysis. So we looked at it in quartiles. And this paper we published in Environmental Health Perspectives, where, do you remember the inverted U shape from the beginning? When Heidi, or Dr. Sukru, brought in the data and showed us these graphs, it was like, wow, everything was hypothesized was there in the data. So even after factoring in numerous covariates, including parent IQ, because that's very important, tobacco smoke, not just self-reported, we had cotinine in the child, we had socioeconomic status, every covariate we could think of. Did they own their home, rent their home, etc.? And we still found that full-scale IQ, we had this inverted U shape where low levels of manganese in both hair and in blood, low levels were detrimental just as the high levels were. Very fascinating. So I'll go back to this one and just sit on that. So again, another detour, another wrinkle in my head were beadlines. The Ohio came out with, in 2010, what was called the Ohio Air Toxics Report. They immediately published all of their data December 2010. I remember it like it was almost yesterday. And I immediately looked for, because they have stationary air samples around the state. And I was zoomed in on what's the manganese concentration. So, because I was looking for my town, Marietta, right? It's got to be the worst one, right? Because I'm there, we're doing this study. Here's Washington County, where Marietta sits. Washington County's at the top. So my eyes were like, what? Who's this? Wrinkle. Like, what is going on? Well, there's three. You can see they're all kind of clustered. There's huge differences. This is Columbiana County. What is going on in Columbiana County? Not too long after I see this data, I get a phone call from a community activist saying, we've seen this data. And we were in East Liverpool, this is East Liverpool, they had I like to be factual on this, but I think it's the largest hazardous waste incinerator in their community. And they had tried forever. They actually tried to stop having it sited there. They didn't want it, but it came anyway. So they had been fighting it for decades. So they were looking to see things related to the incinerator. Well, they saw the manganese. And then, I get a phone call because we had been publishing in Marietta and working with them. And they're like, well, what could you do? Could you do, what could we do for our town? So all right, let's think about this. But we have to have partnership. We have to have community engagement throughout this process. I can't just walk into your town. I need to be invited. So they took this information to the Ohio, one of their little health department meetings. They had the East Liverpool City Health Department. They had a meeting. They talked about manganese and these data that they saw. And then they talked about this Dr. Haynes from Cincinnati. And then they said, well, we want her to come and look at, it was actually the superintendent of the schools, and said, we want her to come and look at, hair concentrations in our kids, and then try to build a study. So we did. I'll show you that one. But here's the EPA has a reference concentration, and it's right here on this line. So all of these communities have higher, but the EPA reference is like way down here, and look how, you just want to run in and it's like, okay, what can we do? So here is East Liverpool. So how did I miss them, right? You're supposed to be assigned to, how'd you miss this bigger source? Well, I'll tell you how I missed it. This is the facility right here on the river. Do you see a stack? No, there's no stacks. So when I was looking for manganese exposure communities, you go to, it's called the Toxic Release Inventory. And every facility that has a stack and they're emitting something has to report. It's a wonderful, obligation that they have to report. But if you don't have a stack, you don't have to report. So they've been undetected, then only if there was a monitor would you know. So I was very grateful that the Ohio EPA had put monitors there, and so that the community could know that the levels were high, because we were unaware of them. So we did the same study. We did a pilot first, and pilots are really helpful, because this was funded, this one in particular, with an R21, but without the pilot, it would be very challenging to get NIHS to, and review study section to buy in. So we're to be very grateful for the CCTS pilot money, for any pilots you can get from your department, etc. Because they can really launch you to bigger things and enable you to do what you want to do. So in East Liverpool, we did the same criteria. We didn't have enough in a R21 to do all the monitoring, but we did the biomarkers and then the outcomes. So again, we don't have that beautiful curve to show. We only had about 150 kids in this component, whereas in the other Marietta group, we had over 300 or so children. But full-scale IQ was significantly associated with hair manganese in this cohort. We published this work, and surprisingly, it was not our best. I'm going to show it's not because we just, it wasn't the big U, it was, unidirectional, but it hit NIEHS at the right time, I think, with the community engagement approach. And it was awarded the October paper of the year from NIEHS, and then ultimately overall paper, one of the papers of the year by NIEHS, which is I think remarkable, because it wasn't, I liked the other paper better. If I could have chosen which one they would have selected, but timing hits sometimes. I think it just hit at the right time. But we also, so here's another little detour piece, but it was key, is giving the results back. So it's very critical, I think, when you're engaging with the public, how do you give it back to them? How can they understand it in a way to make sense out of this? So I'm excited here at UK to begin working with communications and data visualization. So we had a key community group that helped give us advice. We did have some, these are old now, but some infographics But then this is unusual. This is not normal how we share data across our mechanisms. We show crazy figures or bar graphs, and I gave them bar graphs. We gave them the histograms, and they said, oh, do not, do not share that with the community. They won't understand it. You need something, what did they say, colorful. It needs to be bright, it needs to be easy to understand, and with images that we can relate to. So I was like, well, if we're showing them blood, why not a blood tube? And then we just would draw the line of the comparison. That was an important piece. How did they compare with other communities with those levels? So here was here was the pilot study hair level, and then this was a Superfund site in Oklahoma. So we were able to give them some comparison data. And then for individual results, we would draw a line and say either your child was here and the whole study was here. So, and then we published on that, because as a growing investigator, if you don't publish, you perish. So it was like, all right, we got to put this into a paper and get some press out of it. So it was also published by EHP. So right now, we've taken the study when they were 7, 8, and 9, and now we're looking as they are adolescents. So their brains are developing. And who here knows that adolescence is another phase of rapid brain growth? Can I get a heck yes? Anyone with adolescents should be screaming yes. So we are now looking at their adolescent behavior, risk-taking, school achievement. We're also, again, measuring their balance and their gait, everything from, we're looking at that minor, and then how can we put that on to these kids? We're also doing neuroimaging. Again, Kim Cecil was a part of the original lead studies and looking at lead and its impacts on brain. So we are doing a broad scale scope of looking at the impact of manganese on various regions of the brain. We're going to look at the anatomy, the metabolism, the organization of the brain, its function, and connectivity. So it would be great once we have great data to bring her here and she can share that component. And all right, it just transitions into this one. When we gave the data back, we wanted to give it back. All right, so you're a concerned parent. You hear about a study and about manganese and it's in your air. How soon would you like to know what your child's level is? Tomorrow, today, by the time you leave. Well, in research, it might be okay for a clinical setting and you're doing a routine lab, but in a research study, we batch the samples, we send them to New York, they would batch them, they would analyze them months later. Again, I get phone calls. Hi, my kid was in your study, my child. Do you have their, no, I don't have it back yet. So when NIHS came out with new funding mechanisms for developing technology, I had a wonderful mentor who said, you got to go for that. And I was like, technology? I have no idea. I was like, wait a minute, brainstorm. What would I want? If I could create something in tech, what would I want? And I would want a real-time blood metal sensor so that I could give the data back immediately. So did that idea just happen to originate in me spontaneously? No. It was the numerous phone calls from the community, working and seeing the community's response and them wanting it. So I ran across the street, grabbed an engineer, said, hey, is this even possible? Could you develop a lab on a chip or a real-time sensor? And he's like, sure, why not? So we wrote together, this is Dr. Ian Kowalski. He's since left Cincinnati and he's now at the University of Chicago in Illinois. But essentially it's taking all of this wonderful ICP-MS equipment and downsizing it into something smaller than a little computer. You plug it into the computer, put the blood in these little cells, and voila, you'll have the readings and in a short order. So we've been able to secure several awards just to build this. And it was a genius idea, but whose was it really? The community came up with it. So I think I attribute everything I do from the energy that I get from working with them, not on them, but with them. As soon as you have that with approach, it changes it. So then, after we're doing all of our stuff, another detour, another phone call. Chicago, southeast side Chicago. I'm an Appalachian researcher. I've been doing Eastern Appalachian work, Eastern Ohio. Southeast side Chicago, predominantly Hispanic community. They have the exact same company that's in East Liverpool, Ohio, in their town. So a journalist who's writing the story in southeast side Chicago, who saw levels, said, oh, what's going on? They start doing their due diligence to write their article. They saw that paper of the year report from East Liverpool and were like, hey, interview. So of course, I do the interview and I'm like, wait, could you please connect me to the community representative there? Because maybe we could do a research study. And that's where we're headed. We were able to swing NIHS funding to actually now start in Chicago, and we're now hiring 2 women from the community to start doing a study. They're very excited. So just in overall, to show you how big things can get quickly, we now have the ability to look at in utero exposure with the baby teeth, right? And now you can see we also have early feeding because we asked history questionnaires. We can now look at motor function when they are 7, 8, and 9, and now currently 13 and 17. So this is what we're currently able to do. And I hope this other research study gets funded, but the next goal would be to look at individual exposure, run AirMod for every single year that they've been alive and try to identify what their exposure history has been. I'd love to pull their electronic medical records and look at diseases, infections. We're talking manganese and infections with someone else in Vanderbilt. And then also looking at those early life exposures in the teeth. And then following then, 18 plus, psychosocial measures. And then we haven't even really worked with the parents yet. So what an opportunity to bring the parents of these kids in who've had chronic exposure over their entire life. And now that they are going through, maybe they're 45, 50, and start looking at maybe pre-Parkinson or Parkinson-like or early aging markers. So I'm excited again to be here because I can now work with people in the Sanders-Brown group with their long expertise to see how we can build an adult cohort. So if you grab a hold of those community members, even though my way was detoured all over the place, and in retrospect, now as I look back at all those different changes and things that I went through, it's still bright, we're still moving ahead, and I look forward to more detours that the community throws at me because I know it's always going to end up really well because it's so exciting with the ideas that they have. So I know you're clinical research people, and you may have had questions about specific things like recruitment or anything specific about the study, and I'd love to dialogue with you if there's time. Yeah, maybe? Great. Do you want to ask questions? Or not? Yes?
How did you account for you said you compared the kids' IQ to the parents at one point. I mean, how did you account for the parents' exposure?
Yeah.
If that was...
We did not include, this is my thank you slide, we did not include a measure of parent exposure. But I didn't mean that we compared the adult and the child. We haven't done that.
Oh.
But adult, so when you're raised by your primary caregiver, their IQ, more than their job, affects you and your IQ. So we included it as a covariate.
Oh, you controlled.
We controlled for you.
But the parents could have been exposed as well.
They were. I just know they were, yes. So what was the impact on their IQ? That's yet to be, we know, let's do another study. Future's bright. Keep going. There's more questions. Yeah, Vicki.
So can you talk about going back to the community and talking with them about a sensitive subject like,
Yeah.
so we measure these levels and
Right.
we're measuring low IQ.
Yes, and the interaction with the company, because they would want to come and listen also. I do have to say, on that note, that as soon as our research study was funded, as soon as we had, because once you're funded, the university likes to do a press release. As soon as that press release hit, they came out with their own ad in the paper about how great they were, And they started opening the door and said, we want to have a community meeting with you once a month, community group, to learn more about what this study is going on. So immediately they had full access. But how did we handle the tough? Well, as you notice, and I don't have to scan back, but their IQ wasn't bad. They weren't like, they didn't need, there wasn't an IQ that showed like significant remedial impacts. They were all healthy, functioning children. But what we were looking for was subclinical. So if they presented to a clinic, a nurse practitioner would not have said, oh, you're manganese exposed. We can see the green antenna coming out of your head. You know, it was not like that, and it was just subclinical. So when we talked to them about these effects, we're very clear on these are not something your doctor would say, yes, you've been manganese exposed. These are subclinical impacts.